Hello, I'm very happy to see so many of you here because when I went around yesterday to ask who's a Java programmer, everyone's like, not me, I don't do Java. So either there are more Java programmers here than I thought, or you're not Java programmers and you're here to laugh at the fact that Java gets lambdas about 20 years after everyone else. So who is a Java programmer? That's good, excellent, this is a good start. And I can see all the people at the back lurking, ready to leave at any time if this is not going to meet their expectations. But don't worry, these lights are so bright that if you want to have a bit of a snooze and you're stuck in the middle, I won't notice, it's fine. Just give me a green on the way out and we'll call it even. Right, so yes, Java 8 and 9 in anger. Because, you know, I wrote this talk more than 3 weeks ago, and so it's old news, so I had to add Java 9 in. I am a technical advocate / evangelist for JetBrains. I work mostly on IntelliJ IDEA and upsource, which means that I have to sort of stay up to date on trends in terms of Java, JVM languages, and sort of broader design patterns and clean code and stuff like that. Yes, so this is a fully buzzword compliant application, of course, otherwise I can't present it at conferences because otherwise people are too bored. It includes functional idioms, microservices, or services which are kind of small-sized, it's the same thing. Java 8, obviously, but since Java 8 has been out for nearly 3 years now, we have to think not just about Java 8, but also about Java 9. Who's using Java 8? A chunk of you. Who's using Java 6? Some of you. Who's on Android? So the people, never mind. But there's a chunk of you using Java 8. Who's using Java 9? Well, that's good. So there will be some new stuff in here. When we asked that question at DevOps, people put their hands up, and then we had to make sure they won't put it into production yet, because it's not going to be out for like a year. It's really not ready yet. So Java 8 has loads of new features, including stuff around hotspot and security and mission control and other things you are not allowed to read as it goes past that fast. But of course, what most people think about when you're looking at Java 8 is lambda expressions and the streams API. And like I said, most people are kind of laughing at us because everyone else has had lambda expressions in their languages forever, and we're just kind of just about starting to get them in Java. But what I wanted to do is not demonstrate these features in terms of this is the syntax of a lambda expression, and you know this is what a stream operation looks like, but to put it all together in a real-world application with live coding, because Danger is my middle name. It's not really, it's Mary. So I'm going to put it together in a real-world application, and again, because this is fully buzzword compliant, it's going to be a Twitter dashboard which consumes a real-time data feed, puts it through 1 million little services, or 5 services, and parses it, makes sense of it, and displays it on a Twitter dashboard. It's a real-time dashboard. I'm using JavaFX for the dashboard for a couple of reasons. One, I want this talk to be sort of pure Java with as few dependencies as possible, just doing everything as much as possible in just Java 8. And JavaFX comes as part of Java 8. 2, it means I can write things like lambda expressions and streams even in the UI, so I can be demonstrating Java 8 features even in the UI. As I said, this is going to be broken into a series of services. I'm not going to go into this architecture diagram now. We will come to it piece by piece as we build it up. The code is available online on GitHub, so you can go away, take a look at the code. There are a number of different versions of it, so you can look at the branches and sort of figure out how the code has evolved over time. There'll be a link at the end of the presentation which points to a page which has links to all the resources, not just the code and the slides, but also all the reference material I used to build up the application. So let's just dive straight in there. The first thing we're going to build is a leaderboard of top tweeters. So let's imagine you're a conference like this, and maybe you want to look at you want to have a look at who's the most active tweeting on your hashtag for your conference. And so we're going to put the top tweeters at the top of our leaderboard. What I want to do is I want to build this up sort of front end backwards, partly so that I can show you something in the UI, but also because this is sort of a sensible way to build up applications. So I'm going to have a stub service at the back end emitting fake usernames so that I can build the UI off the back of that. So this is the first thing we'll get started on. I'll put my glasses on so I can see something. So this is where we're going to see our first lambda expression. So of the people who are using Java 8, are you like really using Java 8 with lambda expressions and streams? A few of you. Are you compiling against Java 8 on an older code base? some of the same people. So for those of you who've been using Java 8, you've kind of already got the hang of lambda expressions. So I'm going to obviously point out some of the features to some people as if they've never seen it before. But obviously, you people who've been using it before, you can just gloss over that and have a brief snooze. So we've got our first lambda expression, which is here. And what this lambda expression does is we're going to pass it into our stub service, and we're going to pass in the sort of business logic of our stub service. And this business logic is just randomly pick me a username from this list of fake Twitter usernames. Who can spot the Java 9 feature in this code? Anyone? No one's willing to say anything. Yes? These ones? Ah, thank you for pointing that out. It's not a Java 9 feature, it's an IntelliJ 2016.3 feature. So IntelliJ 2016.3 came out last week, and what it does is it uses the names of the parameters for any parameter you pass in as a literal, like strings and numbers, so you can sort of see what it means. It's like my favorite new feature in IntelliJ, so I keep showing it off to everyone. But then everyone thinks it's a Java 9 thing. It's not, it's an IntelliJ thing. So the Java 9 feature is list of, which seems like an insanely simple thing that perhaps we should have had before, which we sort of did actually, because we had arrays.asList, which is effectively the same thing. But what you can also do in Java 9 is not just list of, but more interestingly, set of. And so let's just do that. Turn that into a set. Turn it into a set. Fine, I'll do it the old-fashioned way. So before, if you wanted to create a set sort of offhand like this, you couldn't do that before Java 9. So Java 9's got some really nice things around creating collections sort of as you go. It makes life a little bit easier as a developer. So it's a tiny thing, but it's quite useful. So let's start up the service. And what the service is just going to do is it's going to run /users port 8083. And as I say, like every half a second, it's just going to emit one of these fake Twitter handles. So now that's started, let's go to our UI. Oh, no, let's bring up the slides. So the next thing I want to do is I'm going to create, so that's one service running in the back end, could potentially be running on its own separate server somewhere. And then I'm going to create the MVC side, which is going to consume that service and then display something on the screen. So let's look at our dashboard. This is all, as I said, this is JavaFX. So first we need to connect to the endpoint of that user service. So I'm going to create an endpoint, client endpoint. Let's tell it where to connect to. I've hard-coded in some shortcuts so that I can not mistype the URL. What else do we need? Oh, that's all we need for this. Turn this into the user endpoint. Now I'm going to add a listener to this user endpoint. And this is going to be my leaderboard data. So the way I've kind of created my MVC is I have a model, so I have this data object. I have a really dumb controller, which just wires together the data and the view. If we look at the controller, it's just got the view in here. We'll look at the view in a minute. So yeah, our controller just glues together the view and the data. So our data, because we've added it as a listener, we need to implement message listener. IntelliJ will add the onMessage method. So what do we want to do? This message is the Twitter handle. Let's rename this so it's useful. Let's call it username. What I want to do is I have a hash map of all the Twitter users I've ever seen. And so what I want to do is I either need to get the Twitter user out of the hash map, or if I've never seen them before, create a new Twitter user, put it into the hash map. And then what I want to do is for that Twitter user, increment the count of the number of times I've seen it. Now in the past, we'd have to sort of ask the map, do you have something which has this key? If not, create a new one and then insert it, and it's a bit fiddly. Now with Java 8, all we have to do is just say compute if absent. We give it the key, which is username, and then I'm going to do this the long form way because this is the way that was useful for me to learn how to use lambda expressions as I was going along. We could say, we give it a function, which is, this is the function to call to create a new Twitter user to put into the hash map, which is fairly simple in my case. I just say, I want a new Twitter user with this username. And then IntelliJ can turn that into a lambda expression if I want, or even further, it can just replace it with a method reference. So compute if absent, you say, look for something in the map with this key. If it doesn't exist, call this function in order to create it. So what we'll do then is, this is now our Twitter user. So we just need to increment the number of times we've seen it. And then what I want to do is I want to take this list of all my Twitter users, and I want to sort it in descending order, and then just take the top however many is going to fit on the screen. So this is where we start using our streams. So we say all Twitter users, values, stream. We're going to sort it. So we say sorted. And we could give it a new comparator. Even before Java 8, we used comparators, which was our old school way of doing lambda expressions with our beautiful boilerplate, because we like boilerplate in Java, don't we? We've got a class name and a method name and some types and some more types. So we're going to say Twitter user dot get count minus t1 dot get count. And whenever we were doing comparators, we were like, well, I'm not really sure whether it's the first one minus the second one or the second one minus the first one. Let's just give it a go and see what happens. And then when we collapse that down to a lambda expression, that doesn't necessarily improve things for us. We still have this same problem of, I'm not really sure whether it's supposed to be this one minus that one or the other way around. IntelliJ is suggesting that you can use the new methods on comparator. So comparator has a bunch of new methods like comparing and comparing int. And then all you have to do when you're using that is pass in a method reference of the method you want to compare on. So it's a little bit more readable. And I can actually see in this case that this is going to sort it in ascending order. So I just want to reverse it. So it's a little bit more intuitive when you use things this way. If I want, I can also add a static import so it's not taking up as much space. So I'm going to sort it on tweet count in descending order. Now I want to limit by my magic number of the number of leaders that are going to fit on the board and collect that into a list. So collectors.toList. This is now my top tweeters. Now what I want to do is, this observable list is the JavaFX object that the UI is going to be looking at to decide what to display on the screen. So I need to somehow get into this list all of my top tweeters. So that's fairly straightforward. All I have to do is say items.setAll top tweeters. Except that it's not quite as simple as that. This onMessage method is sat on one thread, listening to my user endpoint and manipulating the data based on the Twitter handles which come in. And the UI thread is using this items list. So I can't change the items list from inside the other thread, because that's not what you're supposed to do. So I can do something a little bit simpler, though. I can pass this functionality to the UI thread to do when it's ready. And I do that by saying platform.runLater, and I give it a lambda expression. So then I don't have this contention between which thread is doing what. I just say to the UI thread, run this piece of functionality when you're ready. I don't have to manage that. OK? So format that. My one-year-old ripped off my control key, so that's my excuse for not being able to do the shortcuts, and I'm sticking to it. Right, so we've sorted out, we're listening to the user service, we're parsing the data, we're sorting it into the values. Now what we want to do is, let's go back to the dashboard. We need to connect to the endpoint, and we need to create the view. So this is JavaFX, so we're going to create a leaderboard. This is going to be a table view. I need to give it an ID. I've told it which controller I'm using with this view, and that happens to have a table view with this ID. So IntelliJ just figured out that's probably the ID I want to use. I'm going to give it a height. I'm going to give it some columns. Oops, that's not right. I'd set up a shortcut so that I can easily create some columns because there's a lot of boilerplate in there. This is going to be called Twitter handle. And I want the width to be 300. I need to do the same thing with, bless you, the count of the tweets. This is tweet count. And my magic numbers that happen to work. So with JavaFX, you can define your UI in Java if you want to. You can define it in XML. And of course, my initial instinct was, ooh, XML, that's nasty. But one of the good things about putting the UI or the view bit in the XML is you're not tempted to put any logic in there. It only defines the view. So it keeps the view quite nicely separated from the model and the controller. So let's go back to our dashboard. Let's start it up and see what's going to go wrong first. Did I start my user test data? Oh, it's working. Amazing. So you can see it's connected into the fake user service because we have these fake Twitter handles. My height's, oh, the resolution's changed, so the height's a bit funny. And we can see that the count is being updated, and it's also resorting it as new Twitter handles come in. So that's kind of cool. That's our leaderboard sorted. All right, so the next thing we want to do is, that's kind of fine, we're looking at Twitter users. Let's do a bit of analysis on the Twitter data. Let's figure out whether your conference attendees, for example, are generally happy, generally sad, or maybe a mix of both happy and sad type emotions. So we're going to display this as a pie chart, and we're going to do the same thing we did with the user service. We're going to have some a mood stub service in the back end so we can build up our UI off this. Now what I want from this is I just want to emit a comma-separated set of values of moods, and this will either be happy, sad, or happy, comma, sad. And so once again, it's just the same thing as the user service. I just randomly pick one of those and emit it every half a second. So we'll get that up and running. And that's going. And we'll create the model view controller for the mood pie chart. So we go back to our dashboard. And we need a new endpoint. So we have a new client endpoint, tweet mood. Connecting to the mood service. Now, what we did before is my user service was quite dumb, and all it was doing was emitting a string, which I can assume to be a Twitter handle. My mood service is emitting a comma-separated set of values. So I would like to do some analysis or parsing of that data before I do anything with it in the UI. So I'm going to give my, my endpoint a lambda expression of how to deal with this data to turn it into something useful. So this is a message handler. We're going to take the message and we do mood parser dot parse the message. And that will return me a tweet mood from my CSV. Now I can shorten that to a method reference too. This is going to be my mood endpoint. Let's bring that up. Now I need to add a listener to my mood endpoint. This is going to be my mood chart data. It's the same sort of pattern as before. We're going to make that implement message listener, implement the on message. Now, I'm going to get this tweet mood from the mood service, and I want to do something based on what the mood is. So if the mood is happy, then I'm going to increment my happy portion. Set pi value happy portion dot get pi value +1. Obviously, I want to do that for all states, so I'm doing copy-paste coding because everyone knows copy-paste coding is the best way to code. I did this with I did this with Robert Martin and Dave Farley watching me do copy-paste coding. I was like, this is not cool. I will fix this. So did I say confused? Yeah. So if it's confused, increment the confused portion. If it's sad, increment the sad portion. Now, of course, because we did copy-paste coding, this is bad, and we don't want to do that. So we'll extract this into a method. We're going to call this increment pi. Oh, by the way, if you're wondering which keyboard shortcuts I'm using, mostly they are flashing up down the bottom, so that should be helpful-ish. So increment pi. Now we're going to pull out all the specific stuff to the sad mood. So we pull that up into a parameter. This is called criteria. Pull this out into a parameter. Call this pi. And now IntelliJ can figure out to replace the other two instances of my copy-paste coding. So that's cool. We've kind of reduced our code down to just 3 calls to the same method. We could go one step further because we are doing Java 8 and we want to lambdify everything, put lambdas in everywhere. So we use the handy keyboard shortcut of Alt, Control, Shift, and P. And we can introduce a functional parameter. So we're going to call this do this thing. Naming is really important. And then that will give me that will change this method. So it takes, oh, let's move that down, sorry. That changed this method call so that now I inject the lambda expression to implement, which is great because we're lambdafying everything, except it's kind of stupid, right? Because we've got like a Boolean value here, and then we do something really stupid. So we can use these kinds of refactorings to sort of figure out whether this gives us anything and play with stuff. But when we see something like this, and we basically just moved our copy-paste coding around into a lambda expression instead of an if statement, then I suggest we use the magic incantation of Control-Z, Control-Z. And then it's much neater. Okay, but you can use the refactoring tools to play with stuff and see what's neater and what's cleaner. So now we are incrementing our pie chart value. Let's go back to our view. Let's connect to our endpoint. Let's glue up our data to our view. Let's create our view. So it's really complicated doing pie charts in JavaFX. What you do is you say, I want a pie chart. I want it to have this ID. I want it to have this title. And that's it. That's all you need to do. And then we run our dashboard. And then we have our nicely animated pie chart, which should, given that we're randomly emitting happy, sad, or happy and sad, should kind of tend towards an even amount on each of our pie slices. Okay, and JavaFX just takes care of all the animation. So I'm not a massive fan of Java as a UI tool, but I'm actually quite happy with JavaFX because you do very little, and it does a lot of the stuff for you without you having to worry about it. Cool, so let's close this down. Where's my cursor gone? My mouse has stopped working, which would be fine, except I need to close that. Right, Control F2. I'm not sure what I just stopped. There we go, fine. That's running, that's not running. Let's kill that. Okay, so what might be quite interesting is not just to track overall mood, but to track mood over time. See if we're getting happier or sadder. So are things making things worse or getting better? And we're going to track these with a bar chart. And here we don't need a new service because we're just going to connect into the mood service, but just do something slightly different with the data. So we'll just connect a new listener to our mood endpoint. Add listener. This is going to be our happiness chart data. We're going to have a look at this. Now the happiness chart data I've already implemented on message because it's really boring and I didn't want to type that in front of you. But here I can show you some new date and time stuff. Has anyone been using new date and time? A few of you. Does anyone like old date and time in Java? No, didn't think so. So new date and time is a little bit easier to use. So I can say I want now. I'm just going to get the minute. Assign that to a variable, now a minute. What I'm going to do with this bar chart is I'm just going to plot for the next 10 minutes whether things are generally getting happier or not. But because of this, what I need to do is I need to set the bar to 0 for every one of those 10 minutes because of the way it's been implemented. So in the olden days, i.e. yesterday, I would have to do for I. I'd do a for loop for I is less than 10. I do initialize bar to 0 for now minute plus I. So now minute is like 55. So for 55, 56, 57, up to 65, I had a mind blank then. Then I'm just going to set the bar to 0 so that I can increment it without getting null pointer. Now, obviously, we're going to use streams for everything, even if it's completely inappropriate. And so we're going to use an int stream for this instead. We use an int stream with a range. We give it the now minute. And we say from now minute to now minute plus 10, we are going to do initialize bar to 0. Okay? It's one line of code less because of the curly braces. It's arguably a bit more readable because you're giving it a range of from now until 10 minutes time, do this thing. So that could be more readable. It's also potentially Could be slower performance because you're creating a whole new int stream and a series of objects to iterate over something when really you've just got 10 things you want to iterate over. So if you're really worried about like nanosecond performance, you probably don't want to do this. But if you do want to sort of get your mindset get into the mindset of doing things in the Java 8 kind of way, this is probably perfectly fine. So it's all a bit kind of swings and roundabouts. But InStream is quite nice for making slightly more readable ways of iterating over things. So let's remove the to-dos, which is a good thing. Go back to our dashboard. We'll wire up our data with our view, create our view. So this is a bar chart. Title is Happiness Over Time. I've got a cheat to be able to do x-axis and y-axis, so I don't have to type as much. The x-axis is the minute, and the y-axis is the count. And then if we restart our dashboard, oh, I need to give it a height. So we can see our bar chart on the left there. As when we tick over to 58 minutes past, in approximately 7 seconds, we should see the next bar increment. So we should see each bar increment as the minutes tick over. This is the worst part of this presentation, just waiting for that to happen. Yay, it worked. And we can tweak the way things are shown. This is not really that important for Java 8, but it's one of the things I quite like about JavaFX is it's fairly easy to tweak the way things look. So I can say what I don't want is, well, I need to give it a height. Happens to be about 600. I need to say, oh, legend. I don't want the legend because it's just taking up space at the bottom. That's that little green blob at the bottom. X-axis, I don't need that to be animated because it's not changing. And the Y-axis, I want the minor tick visible to be false. And then when I restart it, that should have slightly improved the way that the bar chart looks. Slightly. Doesn't make that much difference, but it's just quite nice to be able to easily change things like that. So, although now this resolution, I've never run it in this resolution before. It's kind of mental. What a lovely tiny pie chart I have there. Oh well, it's quite cute. I'm going to keep it. It's like a thumbnail. So let's stop that. Where are we now? We are, is this still running? Okay, so that's all well and good, and I've created a real-time reacting UI based off completely fake services. So it's not really real-time. It's not connected to Twitter. It's not doing anything interesting. So we are going to start doing something with some real Twitter data. Now, I'm not entirely masochistic, so I'm not going to connect to Twitter over conference Wi-Fi because I tried that once and it was a disaster. So what I did is I took real Twitter data and I saved it into a file, and then I've got a service which is going to read that file and emit that real Twitter data. This is also a useful thing in terms of if you're incrementally building your application, you're going to want stub services that do stuff like this, whether it's because you're running them in your continuous delivery pipeline or in order to quickly test stuff or whatever. So my canned tweets service, let's have a look at this. We need to, this is where we're going to use some of the nice features from Java 7, which no one really knew about because everyone went straight from 6 to 8 because no one cared about 7. Poor old 7. So we see some nice of the I/O stuff from Java 7 combined with streams and lambdas, and it works quite nicely together. So we can say files.lines, give it a path, and this will give me, if I surround that with, try with resources, one of the most underrated things in Java these days. So this gives me a stream of strings, which represents every line in the file. And I'm going to add my catch. I'm going to real error handling here. It's like real life. So What I want to do is I'm going to use this stream of lines. What I have is every now and again, one of those lines in the file is the string OK. I'm assuming because of the way I wrote the code to save it from Twitter into the file, you occasionally get some sort of ACK from Twitter saying everything's fine, which is great, except for it makes my service fall over if I include that. So I'm going to filter out this. I'm going to take that if if OK equals S not. Then I'm going to filter out anything that looks like that. I would like to, for each, I'm going to hand that to, I have an endpoint on message. I'm going to give it the line from the file. That can be converted into a method reference. So for every one of those lines, just call this method. What I need to do actually is, when I'm reading from the file, it's actually surprisingly fast. So for the purposes of this demo, I'd like to slow it down. So I'm going to add a peak call, and that peak is going to say add artificial delay. Now, I quite like peak for this. Peak is useful for debugging, so you can do something on every element in the stream at the position where you have peak. What I could have done is I could have said for each and had a 2-line lambda in there, one where I add the artificial delay and the other where I call on message. But by adding it to peak instead of having a 2-line lambda, I've done two things. One, I can shrink this down to a method reference, so that's a bit more compact. And two, when I want to put this into production, I can just get rid of that line, and I know that I've removed my debug code. So peak is quite useful for sort of indicating, oh, I'm doing this to sort of experiment. You probably don't want to check it in. So that's what I want to do there. Now, we haven't seen any Java 9 stuff for ages, so let's take a look at Java 9. Let's try and... infinite streams. Has anyone run into problems with infinite streams? No. Then good for you. The good thing about streams is they can be infinite. The problem is that you don't necessarily know if it's going to be infinite or not. Technically, this isn't infinite because it reads from a file and the file will end at some point. But this service is kind of meant to mimic connecting to Twitter, and that is an infinite stream. So I'm going to be parsing stuff that comes off the socket forever and ever and ever and ever. In Java 8, you can't stop that. Once you're in an infinite stream, that's it. You're done. You're just kind of, anything that you put here, so let's see, what have we got? We have anything you put here, I want to say stop to count down, you're just never, ever going to get to that line, which I can prove you with a test, because I've written tests and everything. And this is before I knew that famous people were going to look at my talk. So if I run this, what we should see is we'll see that I call stop, but the service doesn't stop because I have no way of interrupting that stream. It's just an infinite stream which keeps going forever and ever and ever. In Java 9, I can now stop infinite streams, which is nice. Not quite sure why I wasn't in Java 8. So I can use take while, and I can say I'm going to take this while we're running, let's say. Create a field, running equals true. Let's make it volatile, because we're going to have multiple threads accessing that. So then, what I'm going to do is I'm going to do this operation as long as running is true. And then when running is false, I can stop. So now when I rerun my test, which you see it did end in the end, but that's when we got to the end of the file. When I rerun this, hopefully, we should see it will stop straight away. Oh no, we didn't, because what we need to do is we need to say running is false. Otherwise, it's still going to do it forever. Stop that. The only way to stop an infinite stream, by the way, is like effectively Control-C, kill the process completely, that's it. There we go. So in Java 9, we have take while, which allows you to process the stream until some condition is true, or drop while, which allows you to ignore everything up until some certain point. Now, obviously, the idea is that really you'll be doing some sort of condition on the value in the stream. So take while, you don't see this particular condition. Right, so let's run our canned tweet service. Now, what we can do, now we have a real tweet service, which is, well, a real fake tweet service, which is emitting real tweets. I can now create my real user service. And so I can get rid of my fake user service and extract the Twitter handle from the real tweets. So my user service is going to be new service. User service, let's connect to our new Twitter service. We're going to start it on users port, no. And what we're going to do with this service is we give it a message handler, which is kind of the business logic of this service. So service is just going to be just our plumbing. It's all WebSockets under the covers, and it's going to sort of set up an endpoint over here to connect to some service, another endpoint over here to emit stuff, and all of that plumbing is kind of in the service class. But what it actually does, the business logic of that service, I'm going to put in as a lambda expression. So what do I want to do here? Well, I want to do tweet parser dot get Twitter handle from tweet. So then my whole business logic for this service is just kind of injected into the service as a method reference. And while we're here, let's show you some more Java 9. This is an interface. So Java 8 allows you to put static methods on interfaces. And so I decided for this method, they're kind of helper util methods. I decided to put them on an interface so that there would be no state on this class. What's kind of interesting about this is in Java 9, you can have private methods on interfaces. Now that might sound really ridiculous because the whole point about an interface is to have public methods that you're going to have to implement. But once you start having behavior in your methods, for example, default methods and static methods, then you might need to reuse some stuff. So these two methods both need very similar bits of code, so I've extracted that as a private method in my interface. So let's stop our test data. Let's restart our canned tweets service because the file is of finite length. Let's restart our real user service and restart our dashboard. So now we have real Twitter handles going up onto our leaderboard, as you can tell, because they're really nasty names. And at some point, you'll see all the bots float to the top of that. So next up, we still have time. I'm not optimistic enough to know that we're going to have time for questions, but we've still got time for the code. Right, so now the kind of interesting bit that everyone was probably thinking was going to be some sort of machine learning, amazing analysis. Spoiler, it's not, okay? But what we're going to do is replace our fake mood service with a real mood service, which is going to analyze our tweets. So let's stop our test mood service. Let's go to our mood service, our new one. We want a new service again. We're going to give it mood service, connect to the Twitter service. We are going to run at moods. We're going to give it the port. And we're going to give it a handler. This is going to be mood analyzer dot analyze mood with a message. So once again, in this service, the kind of business logic is represented by a method reference, which I'm just going to poke into the service. So I'm reusing all this code without having to copy and paste code. It's one of the beauties of being able to pass around behavior. So let's have a look at analyze mood. Here's another Java 9 feature. It's the same as the list.of, but it's quite nice because you can use it for maps. So now with maps, I can create myself a map on the fly much more easily than I could before. Granted, it's not the nice syntax that we get with something like Groovy, but it is an improvement over the sort of static method block I had there before. If my map was smaller, let's say it was this many entries, I could actually just say, I could simplify this a lot. I could say map of, I'd say happy, happy, good, good, etc. And I can just give it a finite number of key value pairs to initialize this map with. It's, like I say, it's not got some of the nice syntax of something like Groovy, but it is going to save you a lot of code in Java 9. Right, so what I want to do is I've taken my 140 character tweet message and I've split it into an array of strings where each string is one of the words in the message. I'm going to do this with test-driven development, and I'm very sad that Robert Martin is not here to watch this version of the code, but that's fine. I already had the tests. What I want to do, let's run this. This is a Spock test. I'm a massive fan of Spock. And what I'm going to do is I pass in something like a message of I'm so happy today. What I want to see is that I get back a string of happy. The same with sad. I'm going to get back a string of sad, and then more complex use cases as I go along. So let's just try and fix each one of these tests as we go along. Let's get them all on the screen. So at the moment I'm getting null. That's because I'm returning null by default. Let's say we can either do stream.of words in message, or we can do arrays.stream words in message. Both is the same way of getting an array into a stream. Now, what do I want to do? Well, clearly I want to map one of the words, or all of the words if you like, in the message into either happy or sad. So we'll do a map operation. I'm going to take this string and I'm going to do word to mood.get with the string, which can be simplified. So I've now got a mood for that word in the stream. And then let's say I'm going to find my first one, or else null. If you didn't find anything, return null. Let's assign that to, let's call this return value. Now, obviously, this is a mood. Now, I don't want to return a mood. I want to return a string. So what I need to do here then is an additional map operation where I'm going to map that enum to a string and then change my type. All right, now, if I rerun my test, we should see the first two tests go green because now I'm going to be returning happy or sad. Oh, but look, this is why test-driven development is good. Look, you did something really stupid. Because word to mood, when you're going to get something from the map, some of those words are not going to have an entry in the map. So sometimes I'm going to get null back. So I need to filter out all my nulls. So a mood is not equal to null, which again can be simplified to a method reference. I quite like using objects non-null as a method reference instead of using not equal to null or equal to null, because then it's a bit clearer what you're filtering in or out in the stream. That's my personal preference. So if I rerun that, then my first two tests go green, so I can correctly identify if there's a happy word in there or a sad word. Now, if I have a message which doesn't have any mood associated with it, I want to return an empty string, not null. So I can easily fix this. My or else, I'm going to return empty string, and then that should pass that test. So you can see, especially if you're doing TDD, this can kind of help you build up quite a complex stream operation in stages, because each stage you're going to think about what you need to do for the next stage. My next thing is, should correctly identify happy messages that are not lowercase. So here I'm using a happy word, but it's got an uppercase, and my mood analyzer has all lowercase words. So again, what I need to do is I need an additional map operation, which is going to be string to lower, oh, not top, to lowercase. So that's made that test pass. Now what we've got is what I said, the business logic I decided on as the business owner was that I would, oh, well, I suppose I'll come to that in a minute. That I want to be able to show things as a comma-separated set of values. So I want to show all the moods in this message, not just the first mood in the message. So if I have a tweet which is sad and happy, then I want to emit this sad, comma, happy. Now what we're doing in our mood analyzer is we're just finding the first one. So we don't want to find the first one, we want to return all of them. So we'll collect all of the values that we find. We'll use collectors joining, and we'll give it a comma. This is one of my favorite things about Java 8. You can create comma-separated sets of values without having to iterate over and then take the comma off the last one or decide, am I the first one, am I the last one, am I supposed to put comma on there? All you do is use collectors.joining and it will give you a CSV set of values. So what I was expecting to see here is I want to see sad, happy. So when I rerun this, now I'm doing this joining, I should get CSV set of values. So that works now. And the last one is I decided that I only want to show, I don't care how sad it is or how happy it is. So if I've got loads of sad values and one happy value, I don't care. I actually just want to see that there is a mix of emotions. So that means that what I need to do here is I just want to get the distinct moods. And then when I run that, all my tests should pass. Ta-da, we're all green. We like green. Green is good. There is an additional step we could do. We could actually say, once we've mapped all our words to lowercase, we could also add distinct in there. So we only process the distinct words in the sentence. The unit test won't identify whether that gives you any value because it doesn't change the behavior. But what would be more interesting there is a performance test to see if that actually makes any difference whatsoever. Okay, so this is our mood service. This is how we analyze our mood. We're going to get rid of, we're going to inline that. We go back and restart our mood service. In fact, we probably need to restart everything at this stage because, did I mention these aren't really microservices? There's no resilience, there's no tracing, there's no monitoring, there's just a lot of services. So when you want to see things like resilience and monitoring and tracing, and that's what Josh's talk is going to be really good for because he's going to build up a bunch of real microservices that do microservice-y type stuff, like failover and things like that. So I restart my can tweet service. I restart my user service. I'm going to start my mood service. And I'm going to start my dashboard. What's going to go wrong now? This has all gone far too well so far. I told you. Oh no, it's working. Yes, it works. So I can tell it's working. Yes, I can tell this is real tweet data because this is all tweet data that was recorded on a Saturday morning, and people are largely happy. It's quite surprising. So we have our real-time Twitter dashboard reacting to real-time Twitter data using Java 8, etc. So let's just finish off. What have we learned? We have learned that live coding is fraught with danger. The Streams API is all about what to do, not how to do it. Now, you've been using Java 8, so you kind of know this already. It's not about this is how you iterate over something and pull stuff out. The Streams API is give me the distinct values or sort it by this. And it's a much more, it's a different way of doing things to the way that Java's been doing stuff. It's a much more kind of functional-ish style of doing things. Lambda expressions is about passing around behavior. Before we could pass around objects, now we can pass around behavior. For example, where we told the UI thread, run this bit of code later when you're ready. And there's a bit more around functional thinking. Of course, there's some stuff around when you're doing things like iterating over collections and stuff, it's a good idea if you don't change those collections under the covers because, that tends to lead to bad things. So there's a bit more functional thinking in Java 8. But Java 8 is definitely not a functional language, and Java will never become a functional language. We just steal the bits we like from other languages. And we saw a bit about designing for independent services. So all of those services were running independently. They were running at their own URI. They're running in their own port. And you could see how that application can be split into things that could potentially be running on different services or different machines. As I said, Josh is more likely to talk about how to make it a proper microservices architecture where if one thing goes away, it will be resilient and self-healing and stuff. This is not that. Because this is pure Java with very few dependencies, so that's much more difficult to home grow. All the resources for this talk are here. There's videos of the talk, there's slides, there's code, there's loads of links to things like, I'm using WebSockets under the covers, so all the resources I used to find out about WebSockets, about the Java 8 functionality, microservices is all available at that link. Thank you very much.